All right. Okay.
It's pretty easy.
It's pretty easy. Okay. Okay. So I'm just gonna slowly you can pause. Okay. In case you need to go back. I don't think you will. We're all here today, which is very convenient. But here we go. So I would feel so bad. I'd like redo it at home. So this is called a binomial square. Most missed thing ever. What is the mistake most people do when they say 4j minus 7k quantity squared? Ellis, what are you going to do?
I'm going to square the 4 and the 7 as well as the j and the k.
Okay, and if you square both of those, so then that's going to give you 16j squared minus 49k squared. Is that right or is that wrong? This is totally wrong. Are you supposed to make it negative? That is one mistake. Yes. We do need to write it out 2 times. Now, I don't write it out 2 times because I know the pattern. I've done it so much I can do it in my head. But as a standard rule of thumb, just write it out 2 times and you need to multiply it together. You need to FOIL it. F-O-I-L. First times first. The outer. So we get 4j times 4j, which is 16j squared. Good. And then 4j times negative 7k. Negative 28jk. All right. And then we also have to distribute that negative 7k. All right. So negative 7k times 4j. Another negative 28jk. And then negative 7 times negative 7k. Sorry, negative 7k times negative 7k is 49k. Positive 49k squared. So we get a very different thing than that silly shortcut. We cannot distribute the power because there's a subtraction or addition in between. If it was all a product, like what we did yesterday, if it was just multiplication, can you then distribute the power? Yes. But it doesn't distribute across addition and subtraction. You got to write it out. So we are going to get here, when we clean this up, 16j squared. We got a lot of negatives here. Negative 56jk plus 49k squared. And what would you call that? Quadratic trinomial. Quadratic trinomial.
It's non-standard form.
So, standard form, I would just leave it like this because this is a special pattern, actually. So any binomial square is always going to sort of look the same, have the same pattern. So you can just leave it like that. Yeah, Avery.
If you were to put it in like order, would it go alphabetically?
Typically, yes. If there's multiple letters, we would use them alphabetically. So JK. If you wrote KJ, it wouldn't be different because it doesn't matter. Yeah, it doesn't matter. So, yeah, if you change the order, so if I put the 49k squared in front, does it change the problem? No. So again, we can rearrange things at will. And it also doesn't matter if you do like, if we put negative 56kj, again, those are all multiplied together. So just switching the order, that's allowed. 4 times 5 is the same as 5 times 4. So yeah, that doesn't matter. Okay. What would you do for 16?
I would like separate it into 2 because I would start with 2b plus 3 and then 2b minus 3. Except like they would cancel themselves out a little bit.
Oh.
And then when we get the total of that, then it would be 3b plus 1.
Then you would multiply that. Okay. Very good. I love that you said that you noticed, because I didn't, that these are a special pattern. Yeah, they are the sum and difference pattern. And so that makes it really nice because that multiplies easily. So if we were to FOIL these together, 2v times 2v is 4v squared. And what happens when we do the outside product? What do we get? Negative 6v. But then when we do the inside, what are we going to get? Positive 6v. So those go away, which is super handy. And then last times last is going to be negative 9. All right, so that product simplifies very easily to 4v squared minus 9. And now I still have to multiply in the negative 3v plus 1.
Which we already know.
Which we already know?
Know how to do that.
Oh, gotcha. So you don't need to do any more of that. Yeah? Okay. So you would want to multiply those as well, together as well. But are you good with me stopping right there? You know that there's a little bit more to do? Yeah? Distribute my like terms? Okay. What about this one? This is a good box method one. Do we need to see this on the box method? Or you can super distribute it. That also works, but it's crazy. Okay. All right. These are a little annoying, so I'm going to stop right there. We're going to just look at number.
It's just a word problem.
All right. A triangle has a base of 3x plus 7 and a height of 5x minus 1. Hey, I'm going to draw a picture. Triangle. A triangle has a base of 3x plus 7 and a height of 5x minus 1. So there's my height. Base and height are always perpendicular, so that thing is 5x minus 1. A second triangle is drawn with a base that is tripled and a height that is doubled. Hey. If the base is tripled, what would that new base be? What does it mean to triple it? Times it by 3. So we have the base, and we're going to triple the base. What do we get when we triple this base here? 9x plus 21. So that's our new base. Are you with me there? Yeah? Okay. And then it says the height. So here was the height. A height that is doubled. So if I take that height and double it, what do you get? 10x minus 2. All right. Okay. So then it says find the difference between the area of the original and the area of the new. So our goal is to find the difference between the area of the original and the area of the new. So I'm going to start by finding the area of original. How do we find the area of this triangle here? Very good. Base times height divided by 2, or 1/2 base times height. And what's our base? 3x plus 7. And what's our height? 5x minus 1. Good. Okay. All right. I'm going to go ahead and multiply these together. I'm going to leave the 1/2 out in front for a moment here. I can do this in my head, so I'm going to do that. 3x times 5x is 15x squared. The outside is negative 3x, and the inside is 35x. Negative 3x and 35x's gives me 32x's. And last times last is negative 7. 7 times negative 1 is negative 7. All right, and then I need to go ahead and distribute in the 1/2. What's half of 15? 7.5 x's squared. What's half of 32? 16x. What's half of -7? -3.5. All right, so now area of new triangle. Again, we have a 1/2 base times height with that new tripled and doubled. So the triple base was 9x plus 21. And the doubled height was 10x minus 2. All right. Again, I'm going to multiply my bubbles together here. That's going to give me how many x's squared? 90 x's squared. Very good. I have negative 18 x's and holy cannoli. I don't know what that is. 210. All right. Minus 18. What do we get? 192. Good. 192 x's. And then 21 times -2 is -42. Crazy. All right. Half of 90 is 45 x's squared. Half of 192 is 96 x's. And half of 42 is 21. And it wants us to find the difference between those areas. Yes, we do. How do you suppose we should subtract this? Are we going to do original minus the new one? Or are we going to do the new one minus the original? New minus original. Why? Yeah, the original one is got less area, right? Right, and can area really be negative? Would that make sense? No. So we definitely are going to do the 45x squared plus 96x minus 21 and subtract the smaller area because this is geometry. So it better be real, you know. All right. Let's see. 45 minus 7.5 is 37.5 x squared. 96 plus 16 is, oh, sorry. 96 minus 16, thank you, is 80, thank you. And then negative 21 plus 3.5. Oh, negative 21 minus a negative 3.5 would be plus. That'd be negative 17.5. Oh, all right, that was a lot. All right. Do you have any questions? Okay. Use your time wisely. I'm going to pass out this homework.